17 large turbines and generators inside. Because these machines were too large, he had to figure out a way to transport them to the power plant at the bottom of the dam, because tower cranes could not complete this task at all. Therefore, the engineer erected multiple cable installations in the canyon. Then, he used pulleys to transport the power generation equipment to the rail cars outside the power plant. Then, trains transported them to different areas for installation. These turbines have many blades, which are wrapped by pipes. When water enters the pipes, it pushes the blades to make the wheel rotate. A generator is connected below the turbine. The rotating turbine drives the generator to produce electricity. These processes seem simple, but in reality, directing water into the turbine is not easy. The engineer had to use explosives to dig a tunnel. He used conveyor belts and other equipment to dig and clear the dirt and rocks. After the tunnel was dug, he reinforced it with concrete. Then, water could be directed into the turbine pipes. However, an accident occurred again. High-speed flowing water generated enormous impact force that washed away the concrete in the tunnel. The engineer had to replace the concrete with steel pipes. He first bent steel plates and then welded them together. After filling the entire tunnel, he still needed to build a special water intake at the pipe entrance, because traditional drain-style water intakes are easily blocked by debris underwater. Therefore, the engineers specially designed an intake tower with gates. At that time, German spies planned to destroy the dam. They wanted to blow up the intake tower, so debris would go through the pipes into the turbine. This plan was ultimately not implemented, but even if they really blew up one intake tower, it would only destroy one turbine. It would not cause all the turbines to stop operating. Now the power generation facilities are complete. Next, they had to figure out how to transmit the electricity out. Because the distance between the power plant and the ground is about 1,000 feet in height, the power lines could easily touch the rock walls on both sides. Therefore, the engineer built all the power transmission towers at an angle. This way, it could create distance between the power lines and the rock walls. When the dam construction was completed, the engineer discovered that when local rainfall increased, the water level would exceed the dam. This made it easy for the power plant below to be flooded and destroyed by overflowing water. Therefore, he built a spillway on both sides of the dam. Whenever the water level is still 25 feet from the dam height, it will flow into the downstream along the spillways on both sides. Now, the dam is completely finished. Next, they just needed to remove the temporary cofferdam for normal operation. For safety, workers first drilled holes in the cofferdam and embedded explosives. When the opening gradually became larger, they detonated the explosives to remove the cofferdam. Just like that, in 1936, the Hoover Dam was completed and began operation.